Good morning or good afternoon if you are watching this video to catch up on something that you missed in class or to review and go over what we covered in class. So this activity is adapted from lesson 1.3.1 in the PLTW curriculum. We're going to do a series of lessons and activities that come out of that section in the PLTW curriculum, and this is going to cover measuring devices and the precision and the accuracy of the devices that we use. This little blurb here comes from the PLTW curriculum and is their introduction into this activity and what the goals and the main ideas of the activity are. To measure is to estimate, which might surprise you because you're probably not thinking of measuring and estimating as being the same thing. Modern civilization cannot exist without measurement systems. Measurements are everywhere and used every day. Every time you buy gas, check the outside temperature, or step on a weight scale, you rely on a measurement to communicate information. But a measurement is only an estimate of a quantity. Underlying the word estimate there. We can never know the exact measurement of something because the act of measuring always involves uncertainty. You might make an error reading the measurement, and we do make errors reading measurements. In fact, this is the second time I've recorded this video because I made an error in the way that I said something when I was looking at the calipers at the end of the video. The measuring tool could be calibrated improperly. That means that the tool that you're using is off itself. It doesn't actually measure the way that it's advertised. Perhaps the object has imperfections so that you read a different value at slightly different locations on the object. This would be if you were measuring something like a wire. In fact, the PLTW version of this activity has you measuring a wire. And if you measure the diameter of a wire, so you're measuring like basically the thickness of it, at different locations, if the wire has imperfections, you could actually get different measurements for the diameter at different places on the object. And no matter how carefully you measure or read a device, you cannot measure more precisely than the measuring device allows. So the true value of the quantity might be slightly greater or slightly less than what you read on the device. So if you have a bathroom scale that only measures in like pounds, okay, you step on the scale one morning and it says, we'll just say 135 pounds. You cannot tell somebody, I weigh 135.3. And the reason you can't tell somebody that is because your measuring device does not give you that information. It's not that precise. It's not that like accurate and like how many decimal places it goes out. Sometimes a rough estimate of a measurement will meet our needs. I'm in the bottom paragraph. For instance, measuring your mass to the nearest kilogram or weight to the nearest pound on a common digital scale is probably sufficient when recording your weight during an annual physical exam. Unless your weight is a specific issue of concern for you, usually your doctor is okay with something in the vicinity of what you weigh. And so it doesn't matter to your doctor whether you're 135.3 or 134.2. Like, that's good enough. It's depending on your height. That's probably a perfectly healthy weight for you to be at. Let's see. But if you want to measure the mass of a single cell to analyze changes in the cell over time, you need a much more precise estimate, perhaps to the nearest hundredth of a nanogram. Nano, if we're talking metric prefixes, is 10 to the minus ninth, which means that wherever your decimal point is, you move it 9 spaces to the left, probably adding a lot of leading zeros along the way. So that would be a very, very precise instrument. The main point of this is to recognize that how much we know about a particular measurement is, first of all, an estimate, and how good that estimate is a function of, sorry to throw some math terms in there, is a function of how precise the instrument is that we're using. So what do we have in store over the next few days? This is, of course, contingent on what happens with our fusion. If we get into fusion, I might interrupt this, or I might not. I don't know. We'll find out. In the next few days, we will complete a series of activities to practice using different measurement devices. First activity is going to be measuring with a ruler. You're going to estimate the width of a dowel rod to the nearest 1/64th of an inch, provided that our rulers will give you that kind of precision. I'm not at work right now, so I can't go and physically look at one of our rulers. But that's what we're aiming for. So you're going to start by estimating it to the nearest 1/64 of an inch. That actually is really valuable. It hones your estimation skills. It is important for you to have an idea of what an answer should be before you actually calculate or measure something, because that can help you identify whether or not you make a mistake. Then you'll measure the width of the dowel rod to the nearest 1/64 of an inch, and then determine the precision of the ruler by finding the range of measurements for everybody in your group. Activity 2 is an introduction to dial calipers. One of the skills you're expected to attain in this class is that you can use dial calipers. Most of you have probably never used them before. So our second activity will be a lesson on dial calipers, how to zero them, how to measure the 4 different ways, and how to read the display. Zeroing something means that when you are measuring nothing, that the device actually says 0. So if you've ever seen like the scales, sometimes they're in the doctor's office, the scales that have like the little weights that you shift back and forth. Sometimes if nobody is standing on the scale is actually still reading a weight, and that's bad because that means that it's not like zeroed. If nobody's on the scale, it should be reading a 0. Activity 3 will be measuring with the dial calipers, and pretty much what you're going to do is you're going to go back to this piece of activity 1, and you're going to repeat that activity, only this time using something called the dial calipers. And then you will determine the precision of the dial calipers doing the same thing that you did for the ruler. And the last activity will be calibrating the dial calipers, and this has to do with the accuracy. And please forgive me if I ever like misuse those words. It's very easy to do, and I know the difference, and I don't intend to blurt one out when I mean the other one. But accuracy, if you recall, is how close the calipers are getting to a known measurement. And so we will do something with what are called gauge blocks. Gauge blocks are standardized blocks that we know have a particular measurement to them, and we're going to see how close our calipers come to a known measurement. Because the dowel rod, we don't know the measurement. We don't know the accepted measurement for it. And then we'll use the accuracy of our calipers to determine the actual width of the dowel rod. So this slide here is intended to go over how we use a ruler. Now, I'm going to be honest, I don't like using inches because we end up with these fractions in our measurements. So if we look closely at the lines, I think everybody is good with like the big tall lines that have the numbers next to them. Those are your inches. And if you had something that ended in between 1 inch and 2 inches, that most of you could round down or round up to the closest inch if you were asked to measure something to the nearest inch. Then you'll notice these lines that are in between, and they all have different heights. Okay, the tallest of the next few lines represents your ½ inch. Okay, and so if you were asked to measure something to the nearest ½ inch, and it landed like right here, you would round down because the closest ½ inch would be the 1 inch mark. If it landed here, you would round up and you'd say it was closer to 1.5. The next tallest sets of lines represent your 1/4 of an inch. And remember that like 1/2 is the same as 2/4. So you have your fractions at work there. And so if you look at those, you always include the bigger line in there. So you have like 1/4, 2/4, and 3/4. But of course the 2/4 is the same as the 1/2. And you could measure something to the nearest 1/4 of an inch. Then they divide again, and the next tallest set, these represent your 1/8 of an inch. And so those lines, and you'll notice like none of them are marked. Okay, so after you have the numbers for the inches, none of the other lines are actually marked with the intervals that they're measuring. And so you need to know what they are. And remember too that like the ½ inch mark is the same as 4/8. And if you counted how many 8s, we have 1, 2, 3, 4, like you have 4 8s. And then you can probably figure out how this rolls. So the next set of marks, these are your 1/16 of an inch. Okay, and so if you were asked to measure to the nearest 16th of an inch, you would see where something landed, and you would round, like in this case, either down to 1/16 or up to 2/16, which of course would be the same as 1/8. So you do have to have some proficiency with fractions here. If you're not sure, if you know that you tend to mess fractions up, like please raise your hand and ask questions. Like we want to make sure you're doing this right. Now, if you look between the 0 and the 1, you'll notice that we have even a smaller set in here, and these little tick marks represent 1/32 of an inch. So if I were to list all these fractions off to the side, these are going up in what are called powers of 2. And so if you're, depending on where you are in your math, you might recognize these as powers of 2. This would be 2 to the first power, 2 to the second power, 2 squared, 2 to the third power, 2 to the fourth power, 2 to the fifth power, and so forth. You just kind of recognize those numbers if you see. They come up a lot in math, the powers of 2. Each one of these would go to the nearest 1/32 of an inch. But if you think back to what the directions said, you're going to have to go to 1/64 of an inch. And the way that you'll do that is you will estimate in between your 30 of an inch. And so this ruler here can only, let me use a different color. This ruler in this spot here can only accurately measure to 1/16 of an inch, but over here, the ruler can actually measure to 1/32 of an inch accurately because it's actually on there. The 1/64 of an inch will be an estimate. So you're going to take that last digit or last value there and estimate it. And I'll kind of give you an example of what we mean by that. So you put your dowel rod up against the ruler, okay, and you measure something like that, all right? And so, so try to remember how I did this with my ID kids last year. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. It looks like this is measuring at about 9/30, okay? That's the precision of this part of the ruler. But what you'll do is you'll look at it and say, I think it, now, if you think it lands right on the line, then you would just say 9/30, okay? Like if you think it lands right on the line. But if you think it goes a little bit over, but not all the way to the next line, here is what you will do. Is you would say it's at 9.5. And when you cut the 30 in half like that, so you're basically saying 9.5 30, what you're measuring to is, or you're estimating to, is the closest 1/64. So when you're measuring with your dowel rod, if you think it lands on the actual line, then you just count up your 30 seconds and you're good to go. Okay, if you think that it hangs over a little bit, but not enough to take you all the way to the next level, then you would say like 9.5 30, and so forth. And then I'll have you change that to a decimal, but that's like for another activity. Last little slide here is the introduction to the dial calipers. So this is what they look like. They actually extend further off to the right here. So they kind of look a little bit like a ruler, but and we'll have a whole lesson that goes over how to use these, but I want to call your attention to a couple of things. This is the part that you're going to read. You're going to read this bar down here, not the bar at the top here. When you look at this, you'll notice that they're, just like with a ruler, you have like numbers and they're written in certain places. So you'll notice like numbers that are a little bit higher up. You can see the 0. And if you look over here to the right, you can see the 3 where I circled it. The 1 and the 2 are hidden underneath the dial. So, but there's a 1 and a 2 there. So we have, those numbers represent your actual inches. Okay, like those are the actual inch measurements. And so that kind of makes sense. Like that looks, I mean, there's no scale on here, but it doesn't look like they're open that wide. So those are your inches. Now, the numbers that you see in between, this is where I think it gets a little confusing here. The numbers that you're seeing in between, they don't represent, 16ths of an inch or anything, which is nice because we didn't super thrilled working with the fractions. Anyway, those numbers actually represent tenths of an inch. So those are your tenths of an inch. Now, what's weird about them is that the number appears before the line that it represents. So you see the number 1, that line that I'm kind of highlighting there, that line is the 1/10 of an inch. Here's the number 4. If you can see where my little dot is, I don't know if you guys can see the dot. There's the 4. That's the line that represents the 4/10 of an inch. So you see the number before you actually see the line that number is going with. So if you were to read this, like the way that we're seeing it there, it's 0 inches. And now we're going to go into the tenths. You can see the 6, but we're not actually all the way to the line that represents 6/10. So I can see up to the 5/10 of a line. So that's the number I have to put in there. It's past the 5/10, so there's more like out there, but it's not all the way to the 6. So I can't use the 6. So that's something to be really careful of, just the placement of the numbers and then the lines that they represent. Now, to get this to be more precise, we're going to kick over to the dial. These numbers on the dial represent thousandths of an inch. And you're thinking, well, Miss, I don't know if you, thousandths of an inch. You're thinking, Miss Taylor, what happened to the hundredths of an inch? Well, the hundredths of the inch would be the tens place in a thousandths measurement. And so when I'm reading this, so I'm looking at the dial, I see 60 thousandths, and then we can count, and you'll notice the same little deal here where you'll see like one that's like a little bit longer. That's like your halfway point. So that would be 65 right there. That can make it a little bit easier to count. So 65, 66, 67, 68. So I'm going to add in the 68 thousandths, but there's the hundredths place. Okay, the hundredths place is the hundredths place is the tens digit of the thousandths measurement. It's a 68. Now, if you look closely at that, it is a little bit past the 8, but not all the way to the 69. In fact, it's not even halfway to the 69. It's just a tiny little bit past that. So I am going to estimate that at maybe a 1, like 1/10 of the way, maybe 2. I don't think I would go any higher than 2. When you're using the dial calipers, that last digit is an estimate, just like with the ruler. So the ruler measured all the way to the 1/32nd, and then we're going to estimate to the 1/64th, like going halfway between. With the dial calipers, that last digit will be an estimate, but you do have to give it because you can see it. It's possible to estimate. If you think it lands right on the line, then you would put a 0 there to indicate that your best estimate is that it's right on the line. But we can actually see that there. We can see that it's over the 68, and we can see that it's closer to the 68 than it is to the 69. So there is some value in that number, even though it is not actually measured on the caliper itself. So I hope that that actually is a good introduction to how to read it. So that means when we get to the lesson on the dial calipers, you'll have something in your brain to go back to when it comes to reading them. And then of course we'll talk in class about what do these different, this dial and these weird prong looking things and this wheel, like what do they all do? And we'll cover that in a different lesson. So this should give you an idea of where we're headed and some foundation in how we're going to use and read the ruler, as well as how we use and read the dial calipers.